You write code, but have you ever wondered what really happens when you hit run? What is a programming language? When we first learn to code, we learn the syntax of a particular language. We learn how to structure our code using its specific rules. But have you ever stopped to think about what a programming language actually is? Well, at its core, a programming language is simply a set of rules that allows humans to talk to machines. It's like a translator. We write code using words and symbols that the computer understands. And the computer interprets that code to perform actions and solve problems. There are many different programming languages out there, such as Python, JavaScript, Java, and C, just to name a few. Each language has its own syntax and rules, but they all serve the same purpose: to help humans communicate with machines. The word language itself gives us a hint. Just like we use words in a natural language to communicate with other humans, we use code in a programming language to communicate with computers. And just like there are different natural languages spoken around the world, there are also many different programming languages used by programmers. Now let us take a closer look at how these programming languages work and what happens when you write a piece of code. First off, let me explain the difference between compilation and interpretation. I know these terms are thrown around a lot, but what do they actually mean? Let's say I write some code in Python and save it as a file called hello. When I run this file, the code inside of it is executed and the output hello world is printed to the console. But what actually happened when I ran this file? Well, in this case, an interpreter was used to execute the code. The interpreter reads the code line by line and executes it immediately. So when I run hello, Pi, the interpreter reads the first line print, which tells the computer to print the text hello world to the console. Then the interpreter moves on to the next line and executes any code on that line and so on. This is what we call interpreted code. On the other hand, if I were to write the same code in C and save it as a file called hello, C, then we would use a compiler to execute this code. A compiler reads the entire code base all at once and converts it into machine code before executing it. If I were to run hello, see, the compiler would first convert the C code into assembly code, which is a low-level language that is easier for humans to read than machine code. After the assembly code is generated, it is then converted into machine code, which is a language that the computer's processor can understand. Finally, the machine code is executed by the processor to print hello world to the console. This is what we call compiled code. Now, let's see how the code is executed for both scenarios. When we write code in a programming language, whether it be Python or C, the first thing that happens is that the code is saved to a file on our computer. For example, when we save our Python code as hello Pi, it is saved as a text file that contains the code that we wrote. In the case of C, if we were to save our code as hello C, it would also be saved as a text file containing the code written in C. Next, we can run the code by typing the name of the file into the command line interface. For example, if we type Python hello Pi, this tells the operating system to use the Python interpreter to run the code contained within hello Pi. Similarly, if we were to type gcc hello C, this would tell the operating system to use the C compiler to compile and then run the code contained within hello C. When the interpreter or compiler runs the code, it first needs to convert the code that we wrote into something that the computer's processor can understand. In the case of Python, the interpreter converts the code into bytecode, which is a low-level language that is easier for the processor to understand than Python code. The bytecode is then executed by the Python virtual machine, which is a software that runs on top of the processor and executes the bytecode. In the case of C, the compiler converts the C code into assembly code, which is a low-level language that is easier for humans to read than machine code. The assembly code is then converted into machine code, which is a language that the processor can understand. Finally, the machine code is executed directly by the processor to produce the desired output. In general, most programming languages go through a similar process where the code you write needs to be converted into something that the computer's processor can understand before it can be executed. Now that we know how code is executed, let's take a deeper look at what happens to your code after you hit that run button. First, the source code that you've written in a file like hello Pi or hello C is read by either a compiler or an interpreter. Let's take Python as an example. When Python reads the code, it goes through a process called lexical analysis, which is basically scanning the code and breaking it down into smaller components like identifiers, literals, keywords, operators, and so on. After lexical analysis, the code is then parsed, which means it's checked to make sure it follows the syntax rules of the language. If there are any errors at this point, like a misspelled keyword or a missing colon, they will be thrown as exceptions, and the code cannot continue. If the code passes the parsing stage, it then undergoes a process called semantic analysis, which is basically checking to make sure that the code makes sense. For example, it will check to make sure that you not trying to add a string to an integer without converting the string to an integer first. If there are any errors during semantic analysis, they will also be thrown as exceptions. After semantic analysis, the code is converted into a data structure called a syntax tree. A syntax tree is basically a way to represent the code in a more abstract and easier to understand way. The syntax tree is then used to generate the bytecode that I mentioned earlier, which is the low-level language that the Python virtual machine uses to execute the code. At this point, the bytecode is stored in a file with a PIC extension. This file is called the bytecode cache, and it's used to speed up the execution of Python code. The Python virtual machine then reads the bytecode from the bytecode cache and executes it line by line. As the bytecode is executed, each line of code is converted into machine code, which is the language that the computer's processor can understand. The machine code is then executed by the processor to produce the desired output. This is a very simplified explanation of what happens when you run a piece of code. I hope it gives you a better understanding of the different steps involved in the process. Before we finish, I wanted to point out that there are two different designs for programming languages. The first design is a low-level design, like C. Low-level languages are closer to machine language, which means that the code is more difficult for humans to read and write. However, because the code is closer to machine language, it can be executed more efficiently. This means that programs written in a low-level language tend to be faster and use less memory. The second design is a high-level design like Python or Ruby. High-level languages are much easier for humans to read and write, but they are more difficult for the computer to execute. Because high-level languages are more abstract, they require a compiler or interpreter to translate the code into machine language before it can be executed. This added layer of abstraction makes it easier for programmers to write code, but it also introduces potential performance issues. However, many high-level languages like Python and Java have features that make up for their performance limitations. For example, Python is a dynamically typed language, which means that you don't have to specify the type of a variable when you declare it. Instead, the interpreter will figure out the type of the variable based on the value that you assign to it. This makes Python code more flexible and easier to write, but it also means that the interpreter has to do more work when it executes the code. Java is another example of a high-level language that has features that make up for its performance limitations. Java is a garbage-collected language, which means that the programmer does not need to manually allocate or deallocate memory. Instead, the Java virtual machine will automatically manage the memory for you. This makes Java code easier to write, but it also means that the JVM has to do more work when it executes the code. Despite these challenges, high-level languages like Python and Java are becoming more and more popular because they are easier for humans to work with. And thanks to advancements in compiler and interpreter technology, the performance gap between high-level and low-level languages has been narrowing over time. Now you know what happens under the hood when you write code. Which language do you want to dive deeper into next? Thanks for watching. If you enjoyed the video, don't forget to subscribe for more content like this. You can also hit the like button if you found the video helpful.